Hi there, this video is about reducing the noise emissions from radio controlled model aircraft running two-stroke internal combustion engines. The engine on the display there is a SC61. It runs on 5% nitro fuel. It's fitted with a 13B8 APC Sport propeller, and it's been noise tested to the standards of the BMFA recommendations, and the reading came out at 83 decibels at 9,000 revs per minute. This had a modification, a simple modification of inserting just a metal disc like a washer with a 4mm hole in the middle to take the fixing bolt, and then 4 additional holes, and these holes were worked out to give you an approximate same sort of area as the actual outlet on the manufacturer's silencer. And this was inserted into the rear end of the silencer. As you can see, it just goes in there, and it's just quite a nice fit where the taper at the back there, you can't quite see it very well, but where the taper fits in, so it is restricting the gases quite a bit, The readings on this one was 82 decibels at 8,800 revs per minute, so it did achieve 1 decibel noise reduction and perhaps a 200 RPM reduction in efficiency. But this was taken on different days, so there may have been a slight difference in weather conditions, atmospheric pressure, which could account for the 200 revs per minute reduction in efficiency. Right, modification 2, a little bit more involved. You'll need access to a lathe to complete this one. It consists of aluminium tube. The tube was selected to correspond to approximately the same length as the original end of the silencer, because this is not going to be used now. The actual end will be taken over by this piece. That's 38mm diameter, outside diameter, and it's got a wall thickness of approximately 1.5 millimeters. Just the end of the tube had to be just machined in the lathe just to take a few thou off, so it's going to fit in there really a snug fit. The better the fit, the more it's going to sort of make it, oil proof, so you don't get any leakages of gases. Also, what we have there is another piece of aluminium tube, which is 12.5mm diameter with a 1mm wall thickness, and we have a piece of aluminium plate which I think is just over 2.5mm, we'll say, and that's been cut out of with a jigsaw out of flat sheet and then put in the lathe, and the outside diameter has been turned down to make it another snug fit in that original manufacturer's silencer. These two are fixed together. The small tube has been put into the lathe and the end reduced by about 0.3 of a mil to create a shoulder, and then a hole is put into the disc, which has got to be a really good tight fit on this diameter, so that this can be pressed in there. It's quite a press fit, so it's an interference fit, and it's been made a little bit longer so that you can it protrudes after it's been pressed in. It protrudes over there, and then that can be peened over with a little ball peen hammer and flattened down, and that makes a really strong connection. And there's a 4mm hole in the middle to take the original sort of bolt that goes to there and holds it together, and also these little holes, there's 3 of those, 2mm. That's just to let any excess oil drain out from the main chamber there. Now these two go together. When they're put together, they just butt up against one another, and you can see when you look inside there that there needs to be, it's carefully, you know, worked out so that that hole that you put in there, so it just doesn't foul the side of this tube here. And at the other end of that then we have a similar sort of item. The disc is cut out from a flat piece of aluminium, a little bit thicker there. We're talking about just over 3mm, and the tube is exactly the same diameter, and it's cut quite a bit longer, and then this end is turned down again about 3.3 of a mil, and then there's an interference fit in there again. This is then pressed into there, and that's got to make a really gas tight fitting, and it's got to be that tight that it won't rattle loose. But if it does, say in the future, rattle loose, that could always be welded in with you know, this soft aluminium type of welding gear you can get now. There's also, that's been put in the lathe and turned, doesn't matter really about the outside diameter as long as it matches this one here on the big tube. But there is a recess then, see that little recess, it's about 1 millimetre wide, and it's a nice tight fit in this main body tube. So that's more or less a press fit in there. You want that to be as gas tight as possible, really. The other thing is the length of the tube is quite important. You see, it doesn't go to the end of there, so the gas can come through into this compartment, and there's an escapement route there, and the same with the other end. That goes into about the same. So the object is of this, the gas has got to go through there, it's got to enter this chamber, it's got to go all the way along to the back of the chamber, and then it's picked up on the other end by this tube and it goes out to the exhaust. These need really to be aligned, say at 180 degrees apart, and then again you'll notice that there's a little hole there, 2mm, just in case, you know, excess oil can finally drain out of the silencer. It goes together quite nicely. When it's all together it looks pretty well the same, apart from being flat on the end as the original manufacturer's silencer. And we've tested that again with the noise testing according to the BMFA recommendations, and that brought the noise down to 78 decibels and at 8,700 revs per minute. So that's quite a bit of a, you know, a gain in the noise reduction, with perhaps 300, you know, with a 300 loss of the RPM. So I think that's probably worth looking into. It does quite a good job of reducing the noise quite a bit.